Bismillahirrahmanirrahim. Today, inshallah, we will begin our study of hyperbolas. Hyperbolas tend to be one of the more trickier conic sections for students to appreciate, but we will take it gradually, and I think, inshallah, by the time we've done our study of it, you have a pretty strong grasp of the fundamental concepts of this conic section. As a way of introduction, I like to review the ellipse, because the equation of the hyperbola is almost identical to the ellipse, and it's the small tiny difference that makes a whole world of difference in the graphing and the manipulation of these functions. So if you recall, the general equation of the ellipse was like this: quantity x minus vx squared or divided by a squared plus y minus vy squared, where b squared equals 1. And the Vx and Vy were pseudo vertices, and A and B were the major and minor axes. So as an example here, I've given you an ellipse. So here's x squared over 25 plus y squared over 16 equals 1. And in this case, Vx and Vy is 0, and therefore this ellipse is going to be centered at the origin. So in other words, the origin is the pseudo vertex, so to speak, or the center here of this ellipse. All right, and then after this, I'm going to take the liberty of graphing this. This is a squared, so in the x direction, 1, 2, 3, 4, 5. That okay, and 1, 2, 3, 4, 5. That would be the two vertices. And so let me just label those. X is 5, y is 0, x is negative 5, y is 0, and then the pseudo vertices would be square root of this, right? So it'd be plus or minus 4, 1, 2, or co-vertices, I meant to say 1, 2, 3, 4, x is 0, y is positive 4, 1, 2, 3, 4. I should label some of these points. X is 0, minus 4. So let me just do that. That's 2, that's 4, negative 2, negative 4. Sometimes it just pays to be a little bit patient, I think. And then I can kind of draw out this ellipse. Let me try to do it over here. I'll do the artistic version of it, taking artistic liberties, so to speak. And here it is. Okay. You get the idea. This kind of looks nicer anyway. So there is my ellipse. Okay. Now, if I were to graph the following equation, following function, and x squared over 25 minus y squared over 16 equals 1, the only difference being right here in the negative sign, and that would give me hyperbola. So the difference between an equation of an ellipse and hyperbola is very small, but it makes a very big difference. Now observe. Now I have drawn this over here, and here it says x squared over 25, y squared 16. This is the ellipse that we just drew. Now over here I have almost written the equation of the hyperbola. If I put that 1 over there, then we'll complete that equation, and then we'll have hyperbola. Now look, the only difference here is going to be this negative sign. And look what happens when you do that. Ready? On the count of 3. 1, 2, ta-da. Look what a remarkable difference it is when you just make that little tiny difference. Okay, and I'm going to switch this to a positive sign, like this. Okay, now observe what happens. Now they're the same equation. Now observe what happens if I put a negative sign in front of the x. It's another hyperbola. Now that is the difference between a hyperbola and an ellipse, and in an ellipse, both the x and y terms are positive. In a hyperbola, one or the other one, either the x or the y term, is negative. And that is the difference between ellipse and hyperbola in terms of their equations, okay? Now, so the general equation for a hyperbola, then, I'm just going to write it out over here, is going to be this: x minus vx quantity squared over a squared, okay, minus, all right, y minus vy squared over b squared is equal to 1. Now then the other version, where I put the negative sign over here, you can write it like this: negative time quantity of x minus vx squared over a squared minus y minus vy plus y minus vy squared over b squared equals 1. You can do it that way, but typically what's done is that you'd like to keep the minus sign in the middle and then just switch the tops and like this, okay? So the second version of this equation would be y minus vy squared over a squared, just keep the a there, minus, okay, x minus vx squared over b squared is equal to 1. Now that's it. So those are the two equations. Now there are two of them, right? And the two will give either hyperbolas that look like this, or they're hyperbolas that look like this. So there are two types of hyperbolas. These are called horizontal hyperbolas, and these are called vertical hyperbolas. And we'll develop that concept in a little bit. Now, so this is, you gotta know, simple as that. And if you understand this, everything kind of evolves from those two basic equations. Now, to develop this concept, what I like to do is the following, okay? What I'm going to do is I'm going to make some horizontal and vertical lines, all right? So let me try to use this color over here. Now, from here, from the major axis, okay, I'm going to try to draw this line over here. And then from here, draw this line over here. And then from here, I'm going to draw this line over here. And from here, I'm going to draw this line. Okay, so what I have done now is, in effect, I have kind of like rectangulated this ellipse. Okay, so I have done that, correct? Now, if you observe, if you do that, now from here to here, oopsie daisy, so I've got to go back to my pencil. From here to here is going to be A, and from here to here, or from here to here, is going to be B, correct? Okay, major axis and minor axis. Okay, that's fair enough. Now, if you allow me, I'll take the liberty of doing something else. Okay, now I'm going to connect these right here and right here. Okay. Try to make that straight. Okay, and then I'm going to connect these two corners over here like this. Why am I doing this? Just because. Okay, now I've done that. Okay, now to graph this function over here, see, that's what I would have to do. I would have to first kind of make that little rectangle, okay? And how do I make that rectangle? I make A, and I make B, and I got that rectangle, right? I make the rectangle like this, and I draw out these two, what they're going to be asymptotes, and then voila. So I have, this is one of the vertices, and here's a hyperbola. So this is the graph of the hyperbola. Now, we're going to talk about this in detail, but I just wanted to show you the relationship between a hyperbola and an ellipse, how the equations are so similar, and understanding of the one will help you understand the other. Now, this equation that I just did is this equation here. Okay, so to graph this, you kind of almost have to see that the hyperbola is a kind of like a inside out ellipse, okay, and it's kind of like you cut the ellipse here, and kind of like open it up here, and kind of in your imaginations, so to speak, right? So a hyperbola is a inside-out ellipse in a way. Okay, so when you're dealing when you're talking about hyperbolas, you kind of have to keep the two in mind, and it helps a great deal. Okay, now you might be thinking, and we're going to kind of like jettison that thought very quickly. You might be thinking that a hyperbola is kind of like two parabolas, kind of like two parabolas, right? That would be quite wrong, because simply because of these. Those are asymptotes. Correct? And parabola does not have asymptotes. In other words, parabolas, they just keep going and they go wider and wider and wider and wider and wider, whereas this hyperbola does not ever cross this boundary of these asymptotes. So hyperbola is contained within these asymptotes, right? So those asymptotes, therefore, are a very important aspect of the character of the hyperbola. So when you try to graph the hyperbolas, basically you have to make the rectangle thingy, and then you have to make those asymptotes, and you know exactly where the hyperbola is going to be, right? So when drawing hyperbola, what we have to first do is you have to find the pseudo vertex. Okay, in this case, it was quite easy because 0, 0, right? And that for us, it's not going to be very difficult. Okay. And once you've done that, you're going to make that rectangle. Okay, so you're going to make that rectangle, so to speak. Okay, that's going to be that's going to give you the corners that you're going to need to construct. Okay, to construct the asymptotes. Okay. And once you have done the asymptotes, you just simply kind of plot the hyperbola. Then you first thing that might be bothering you is, okay, how do I know hyperbola goes like this way or if it goes that way, right? And that's going to be very easy for us to spot, okay? It's going to be determined by this negative term, and I'm going to explain that to you next time. And so in this case, this term was, the y term was negative, so I know this was a horizontal parabola. It's going to be a very easy thing for you to determine, and we'll talk about that, inshallah, after a brief pause. So this was an introduction to the hyperbola. Inshallah, next time we shall elaborate on this. Until then, as-salatu was-salamu ala rasulillah, assalamu alaikum.